Hi guys, in this video we're going to talk some more about probability, that is the counting principles, the addition and multiplication, permutations, and combinations. We're going to talk about how permutations and combinations differ, and I'll show you how to type that into a calculator when given that representation. So let's look at the definitions. The addition principle is when two or more events have no common outcomes. The total number of outcomes can be calculated by adding up the possible number of outcomes for each event. So the addition principle means we're going to add our outcomes. An example of that would be, suppose you want to buy a new phone. Samsung offers 18 models and Apple offers 15 models. How many models altogether are there to choose from? So we simply take that possible number 18 and the possible 15, we add them together, we get that there are 33 different models. So if the addition principle is adding, the multiplication principle is also the same idea. So it's going to be when you can do one task in A, remember A is just a placeholder, a number of ways, and a second task in B number of ways, then we can find out that both tasks can be done in A times B number of ways. So the example on this one is you're given a choice of 3 different sandwiches. So 3 different sandwiches and 2 different drinks. And remember, we did this before with those trees. So we have 3 different sandwiches and 2 different drinks. So from those 3 sandwiches, we could then break off 2, 2, and 2. So we'd have a total of 1, 2, 3, 4, 5, and 6, which 3 times 2 is that 6. And we call that one a combination, and I'll explain that more here in just a little bit. So let's look at these two and decide, should I be using the addition principle or the multiplication principle? So on this one, Ron is going out to a pasta dinner. There are 3 types of noodles to choose from and 6 choices of veggies. So how many different pasta dinners can Ron order? So on this one, if we have 3 types of noodles, that means we could say A, B, or C noodles. So 3 options there, and 6 veggies. That means each of these could then be paired to one of the 6 veggies to create his order. So this one is that multiplication principle. There is 3 times 6. 3 times 6, because I could have drawn lines to each one of these and figured out, well, each letter has 6 possible veggies to go with it. So 3 of those 6s would give me that 18 different pasta orders. For our second example, while preparing a recording for his application to music school, Bernie must follow very specific requirements. The recording must have 1 classical song and 1 jazz song. Bernie is proficient at 3 classical songs and 2 jazz songs. So assuming the order doesn't matter, how many different recordings could Bernie make? And again, we could have A, B, C on the classical. There would be a possibility of 1 or 2, 1 or 2, 1 or 2 jazz. So this one is also that multiplication principle, 3 times 2. And he could make 6 different recordings. And the order doesn't matter. So we also could have said he had 1 and 2, and each one of those had A, B, and C attached to them. So that order doesn't matter, so it doesn't matter, which is like multiplication. We can flip those, and we still get 6, no matter whether I write 3 times 2 is equal to 6, or 2 times 3 is equal to 6. So on our third example, Carla is selecting animals for a new petting zoo. There are 3 ponies, 6 rabbits. For the goats, Carla has 7. And lastly, there are 3 possibilities of sheep. So in how many different ways can Carla create a petting zoo with 1 of each? So we could set this up. We could make a really big tree diagram. So on this one, we could make a really big tree diagram and say pony 1, pony 2, pony 3, and then draw out this 6 rabbits and the 7 goats and the 3 sheep. But to save us time, we could just apply that multiplication principle. So we'd have 3 ponies, 6 possible rabbits, 7 possible goats, and 3 possible sheep. So if we do that multiplication, we would get 3 times 6 times 7 times 3, which means there are 378 possible ways she could choose one of each animal. Now let's look at what a permutation is. So in mathematics, permutation relates to the act of arranging all the members of a set, remember we talked about what a set is before, into some sequence or order. So in other words, if the set is already ordered, then the rearranging of its elements is called the process of permuting. A permutation is the choice of R things from a set of N things without replacement and where the order matters. So in this one, that is the important part. That order is going to matter. That means we're going to take a choice out of a total number of things, but the order is going to matter. And it can be represented by NPR. And that's where we plug this in. Now, you may not have seen this exclamation point. We call that a factorial. And a factorial means, like if I saw 5 factorial, that means I'm going to take 5 and every number below it down to 1 and multiply them together. So that would be 5 times 4 times 3 times 2. We don't need to do the times 1 because that doesn't change. So 5 factorial is 120. And we can type this on our calculator. And let me pull that up real quick. To type this on our calculator, we press 5. We go into our math menu, and you should at the top have a probability menu. It should be the very last one if you don't have the fraction option that is on the CE or the Python. So then the fourth option here has our lovely exclamation point. It even has this permutation we're talking about. So we can type this into a calculator. We just have to remember which number is going to go where as we go through these problems. So 5 factorial is indeed 120. So on this one, the Mountaineering Club is preparing for a camping trip. They need to replace some of the contents of their first aid kit. So in how many different orders can a roll of medical tape, a bottle of pain medication, and an adhesive bandage be replaced? So we have to determine R and N, where N is that number of things. So there are 3 possible things we're replacing. And R is going to be the order in which we replace them. So we can only put 1 in at a time. So I would say 1. So over here, we would write this as 3P1. And where I see N, again, I'm putting a 3 factorial over 3 minus 1 factorial. And as we talked about a second ago, that is really me saying 3 times 2 times 1 over, now this turns to 2 factorial. So this would be 6 over 2 times 1, which is just 2. So 6 over 2 gives me 3 permutations. 3 permutations. Let's do one more of these. Lila, who has a black belt in karate and kung fu, is practicing for an upcoming belt promotion test. During practice, she wants to run through 5 weapon forms she knows. In how many different orders could she practice these forms? So again, what is our R? What is our N? So R being the number of things, the choices. So she can only practice 1 weapon at a time, but she knows 5 possible choices. So I would write this as 5P1. 5P1, so 5 factorial over 5 minus 1 factorial. And on this one, I'm going to write this out on our calculator so you can see what that looks like. So we could write our fraction by pressing alpha y equals. And then I press 5 math. Remember, go to the one labeled probability at the top. Over, and parentheses are important here, 5 minus 1. Again, math. Over to probability, we're choosing the 4th option. So there are 5 permutations here. She has 5 permutations she could practice the weapons. For our last thing today, we're going to look at combinations. And combinations are selections of objects in a collection in which the order of the selection does not matter. So we can do that in any order. We do not care which order we select them. A combination is the choice of R things from a set of N things without replacement and where order does not matter. So here we have this label. N is the total number of elements in the set. R is the number of selected objects, which we looked at. And again, the factorial symbol is that exclamation point. So the only thing that really changes here is we've added this R factorial over this, or under this, sorry, under this. So let's plug these in. And I've put these definitions across here so we have that all the way through we can fill in. So how many ways are there to choose a team of 3? So our R is 3. From a group of 10, our N is 10. So let's set this up. I would say 10C3, because they didn't tell us that we have to have an order. We don't care who came in first, second, or third. We just need to select 3 people. So 10 factorial over 3 factorial times 10 minus 3 factorial. Then we get an answer. And again, I'm going to use the calculator because we love when we can save time. So alpha y equals 10 factorial, go back to probability, press 4, over 3 factorial, parentheses, and I can just simplify that. 10 minus 3 is 7. 10 minus 3 is 7. And I can get rid of the parentheses there and just put times 7 factorial. So there are 120 ways we could choose 3 people from 10. 120 different ways we could select 3 people out of 10 choices. What about this one? Suppose we have 5 new employees we're selecting from a list of 10 applicants. 10 applicants. So again, order doesn't matter. We don't care who applied first. We're selecting 5 new employees. So we're going to figure out how many ways we can do that. So this would be 10C5. And we would have, again, 10 factorial over 5 factorial times 10 minus 5 factorial. So 10 minus 5 is just going to be that 5. So we'd have 10 factorial over 5 factorial times 5 factorial. And let's see what our calculator says that comes out to be. So remember, I can go up here and grab a previous thing since we have similar numbers here. And I can hover to replace them. So I get 252. So I can go back up. I can press enter while I'm hovering on that and pull that down just so that I don't have to type all those buttons again. I can just change some numbers if I'm working out problems. So 252 ways we could have selected 5 employees out of 10 applicants. And the last thing I really want to talk about is just remember and maybe write this table down if you didn't already write some notes about permutations. Order matters on permutations. So when I say order matters, that means arranging people's digits, numbers, letters, and colors, picking a team captain and then a shortstop and then a pitcher, picking your 2 favorite colors in order. So everybody has a favorite color and probably a second favorite color. That order matters. And placements if you're getting first, second, third. Whereas in combinations, we don't care the order. So we don't care who came in first, second, or third. We're just picking 3. We don't care which color is your favorite. Just pick 2 colors. Or pick 3 members. Or select food or clothes or animals like we did earlier. That order doesn't matter. Those are the big differences. I hope this helps and you guys are ready to practice this in class.